So the first thing we're going to do for our warm-up to go through this is type this function into our calculator and see what it looks like. So I'm going straight to y equals and then typing it in exactly as I see it. So use your second natural log to pull up the e, make sure you got your exponents, and then we go to zoom 6 to get a standard graph, and second graph to pull up the table of values. Just scroll through, see if you can find some nice whole numbers. If not, you're using decimals. So I pulled these points from my table, so I'm going to go plot these on the graph. And if we looked at our calculator graph as well, we should see that it kind of goes straight across and then shoots up, which tells me it is for sure growth. It's growing as we go from left to right. Our transformations are right 2, down 2, and we can tell that from the right 2 is the x minus 2, the down 2 is the minus 2 at the very end there, so it's two different minus 2's that matter. The horizontal asymptote is our k value, so y equals -2. That's because we had this number at the very end. That's what makes your horizontal asymptote. The domain of all exponentials is going to be all real numbers because it goes left forever and right forever. And then the range is our asymptote, -2, up to infinity, because it's everything above this asymptote. Number 2, we're going to start very similarly, straight put it into the calculator. Here we go clear it, type in our fractions, type in everything literally identical to what the paper has. That way we have the best possible shot of finding those values. Look at the graph, see that it's growth, and then go and look into our table. So number 2 was also going to be growth, judging by how it looked in the graph. And let me put a table here. And I'm going to put these on my graph now. So -4, just above 3.1. And then I'm going to connect these dots. It should not cross below our asymptote, which is going to be the horizontal line at y equals 3. So that leads us to our transformations. We have left 3 because of the x plus 3, and then up 3 because of the plus 3 at the very end. So think about your h and k values here. Then the domain is going to be all real numbers. It goes left forever and right forever. And the range is going to be everything above our horizontal asymptote because this is the bottom and it exists everywhere above that. So it's from 3 to positive infinity. On to the back, we're going to go right into our calculator here. So here we're going to y equals and use alpha window to pull up the log with the base of 5. Then we look at the graph, go to our table. All those errors are before the asymptote, so logs typically have errors. So here's my table of values. I'm going to plot these points. And remember, the calculator doesn't show it very well, but logs come from trees which have roots, and it goes straight down. Roots go down into the ground. So we should have this extension down here, even though our calculator didn't show it. So our transformations are just going to be the left 1 caused by that x plus 1, just like if I set that equal to 0 and solved. Our vertical asymptote, because of the left 1, is x equals -1. Remember, all vertical asymptotes are going to be x equals, all horizontals are going to be y equals. Our domain is now everything from -1 to positive infinity because this is the leftmost point here and it exists everywhere to the right. So that's our domain. And then our range is going to be all real numbers because it does go down to negative infinity and it goes up to positive infinity. Even though it's ever so slightly going up at this arrow, it is still going to travel upward. Last problem here, number 4, go straight to the calculator using your log button, not the alpha window because we don't have the base, it's just common log 10. So this one, log, type it in, and then we'll go to our graph, take a look at it, and then go to our table, see all those errors, pull some points. So here's my table. I'm going to start by plotting 3, -2, and so on. And then we want to connect the dots, making sure that we have the root. It goes almost straight down, just avoiding the asymptote, which is at x equals 2. And this comes from that x minus 2. If you solved that for 0, it's the opposite. X minus 2 leads to x equals 2. The minus 2 at the end shifts it down 2. So we have the transformations down 2 and right 2 from that asymptote. The domain is going to be everything from the asymptote to infinity, so from 2 to positive infinity, and the range of logs is going to be negative infinity because it goes down forever, up to positive infinity. Even though it's growing just a little bit, there's nothing blocking it from continuing up.